everyone. I am Shephalika Dhakal, and this is my project presentation for quantitative techniques. I've made an app for Simplex optimization, an app that maximizes the objective function by taking the user input. Uh, Let me just present my screen. Um, okay. So I've made an app using Pulp module and Kinter of Python. So this is a Python program. I've used there's this function that solves the simplex problem, and then we have all of these Kinter code that is basically just the layout and stuff. So let's run this program and see what the app looks like. Okay, so this is the app. Let's just All right. So I also have a few questions over here to test this app. We can see that these are the questions that we did in the classroom. So we have done all of these tables and stuff, a lot of calculations to finally reach a maximum profit value. So let's see if this app gives us the same result. We're just going to input all of these things over here. The way we input is we just enter the coefficient of all the variables. This one, the first row is for the objective function, as we can see, and the remaining are for the constraints. And if there is no existence of certain variables in a constraint, then we just input the coefficient 0. For example, in this first constraint, we can see that we only have x1. So for x2 and x3, we'll enter the coefficient as 0. And also we can choose from the inequalities over here according to our requirement. All right, so let's test this question. We can see that the objective function is 3x1, 5x2, and 2x3. All right, so now moving on to the constraints, we have 1x1, and then the remaining are 0. The equality is this one, and it's 150. The right hand side is 150. The second one is 0, 0, 1 equal to 100, right? And the third one is 10x1 plus 10x2 plus 5x3 is less than equal to 4800. All right. So we have entered all of the things that we need according to the question. And here, by doing all of these table and calculations, we have reached to this answer where x is equal to 150, x2 is equal to 280, and x3 is 100, and the maximum profit is 2050 units. So let's see if we get the same result over here. All right. So after clicking optimize, we can see that the value of x1 is 150, x2 is 280, x3 is 100, and the maximum profit is 2050 right here. All right. So we can see how this app works. And now let's try one more question just to check if it works. Let's run this program again. And we have the application open. And now we're going to try the second question that I have. This is also another question that we solved in class. Let's enter the values. The objective function is 1x1 plus 2x2, 0, because we don't have an x3. Now moving on to the constraints, it's 1x1, 1x2, 0 is less than equal to 20. The next one is 2x1 plus 1x2 plus 0 is less than equal to 30. And the next one is 1x1, 0, 0 is less than equal to 35. So I've entered all the question over here, and let's check what the answer is. The answer over here is we have x1 equals to 0, x2 equals to 20, and x3 does not exist, and the maximum profit is 40. And we've also tested the maximum profit and got the same result. So let's see if the app gives us the same result. Yeah, so as we can see over here, x1 is 0, x2 is 20, x3 does not exist, and the maximum profit is 40. So this is my application that calculates, that optimizes the maximum function. Uh, That's it. Thank you.